In this video, we are going to learn linear programming simplex method. We can solve linear programming problems using two methods, simplex method and graphical method. Graphical method is already there in our video in our channel. Now a simplex method. With an example, we will learn how to solve a problem using simplex method. A furniture manufacturing company plans to make two products, mainly chairs and tables, from its available resources, which consist of 400 board feet of wood and 450 man hours. To make a chair, it requires 5 board feet of wood and 10 man hours and yields a profit of 45 rupees. While each table uses 20 board feet of wood and 15 man hours and has a profit of 80 rupees. How many chairs and tables the company can make so that it gets maximum profit? Formulate the mathematical model, find the optimal solution. So this is a furniture manufacturing company problem. So it want to manufacture two type of products, chairs and tables. So to make chairs and tables, it requires man hours and board feet of wood. So here they are having 400 board feet of wood availability and 450 man hours availability. Then here the data has given that how much wood and how many man hours are required to make a table and chair. So here they have given the profit also. On a chair they'll get a profit of 45 rupees. On a table they'll get profit of 80 rupees. Here the problem is how many chairs and tables they can produce in order to get the maximum profit. So first what we do, let x1 be the number of chairs to be produced and let x2 be the number of tables to be produced. So let it be x1 and x2. So to make a chair, it requires 5 board feet of wood. So for one chair, if it requires 5 board feet of wood, for x1 chairs it requires 5x1 board feet of wood. Likewise, to make a table, it requires 10 board feet of wood. So for 20 board feet of wood, for x2 tables it requires 20x2 board feet of wood. Now coming to the man hours. For one chair it requires 10 man hours. So for x1 chairs it requires 10x1 man hours. And for one table it requires 15 man hours. So for x2 tables it requires 15x2 man hours. So on each chair the profit is 45 rupees. For x1 chairs the profit is 45x1. On each table the profit is 80 rupees. On x2 tables the profit is 80x2. So the max z is equal to, here z is the objective function and we have to maximize the profit. So max z is equal to 45x1 plus 80x2. Here always x1 is greater than or equal to 0 and x2 is always greater than or equal to 0. I will tell you in the later part. So this is the question. Max z is equal to 45x1 plus 80x2 subject to the constraints 5x1 plus 20x2 less than or equal to 400 and 10x1 plus 15x2 less than or equal to 450. This is the constraints corresponding to the board feet of wood and this is the constraint corresponding to the man hours and this is profit function. So first we need to convert the given LPP. This is the mathematical form of the given oral data. Now we need to convert this into an LPP problem. So convert the mathematical model into linear programming problem by adding slack variables. Here S1 and S2 are slack variable. So first observe that in a LPP problem, if the inequality is a less than inequality, then less than or equal to inequality, then add one slack variable to that inequality, then it will become equation. Here also this is less than or equal to inequality, so add another slack variable S2. This will become equation. So max z is equal to 45x1 plus 80x2 plus the cost of the slack variable is always 0. So 0s1 plus 0s2 subject to the constraints 5x1 plus 20x2 plus s1 is equal to 400 and 10x1 plus 15x2 plus s2 is equal to 450, where x1 greater than or equal to 0, x2 greater than or equal to 0 and s1 greater than or equal to 0, s2 greater than or equal to 0. Now take the variables of x1, x2, s1 and s2. So the variables of x1 are 5 and 10, variables of x2 are 20 and 15. The variable of s1 is here 1, the coefficient of s1 is here 1, here there is no s1, so 0. Here the coefficient of s2 is 0, here the coefficient of s2 is 1. Now form a table for the given data. The first entry CB, cost of basis variable, and base BV is basis variables, and XB which is x1, x2, s1 and s2. So first enter the basic variables. Here s1 and s2, the variables which are forming the identity matrix are called as basis variables. So with s1 and s2, here identity matrix is formed. So s1 and s2 are basis variables. Cost of s1 is 0, cost of s2 is 0, and xb is right hand side of the equations, 400, 450. Now x1 coefficients, x2 coefficients, s1 and s2. Now find out z here. This is table 1, z equal to cb, xb. Sigma I is equal to 1 to 2. Here we have only two variables, cbi, xbi. That means multiply cb column and xb column. So 0 into 400 plus 0 into 450, which is equal to 0. Now find out z1 minus c1. z1 minus c1 is cb xij minus cj. Just cb into 5 plus 0 into 10 minus 45. So this is minus 45. x2, z2 minus c2 is also like that. 0 into 20 is plus 0 into 15 minus 50. 80. This is 80. So this is minus 80. z3 minus c3, cb into this s1 column. 0 into 1 plus 0 into 0 minus 0. Okay, it is 0. z4 minus c4 is 0. Now if all the zj minus cj values are greater than or equal to 0, if all zj minus cj's are greater than or equal to 0, the solution is optimal. Otherwise the solution is not optimal. So in this last row, here one negative value is there, another negative value is there. So the solution is not optimal. Greater than or equal to 0 means either it should be 0 or positive. It should not be negative, but here it is negative. So the solution is not optimal. So what we do, we'll do the further process. See, if all the zj minus cj is greater than or equal to 0, then the solution is optimal. Here two of them are less than 0, so we apply simplex criteria. So simplex criteria 1 is, we find the variable which enters the basis, which obtained by taking this formula, minimum of zj minus cj such that zj minus cj less than 0. Simply take minimum of the negative values minus 45 and minus 80. So the minimum value is minus 80. This minus 80 correspond to Z2 minus C2. So it corresponds to X2. Therefore, X2 enters the basis. Now we find the variable which leaves the basis by simplex criteria 2. So the variable which leaves the basis is obtained by taking minimum of xbi by yij such that yij greater than 0. So just take minimum of this xbi by, because here x2 enters the basis, do like this. This is x2. So now take the minimum of 400 by 20 and 450 by 15. So 400 by 20 and 450 by 15. This is equal to minimum of 20 and 30. The minimum value is 20. So this minimum value corresponds to this 400 by 20. This 400 by 20 corresponds to S1. So we say that S1 leaves the basis. S1 leaves the basis. Here this vertical box and horizontal box has crossed here. So this is called as pivot element. Pivot element. Okay, now we will form the new table. So in the new table we have CB, basic variables XB, X1, X2, S2. Why not S1? Because S1 leaves the basis, so we can remove S1 from here. So what enters the basis? X2 enters the basis. So in place of S1 leaves the basis and X2 enters the basis. This is X2 and this is S2. So S2 cost is 0, X2 cost is 80. Now what we need to do, this is the pivot element row. So divide the pivot element row with the pivot element. That means 400 by 20. So 400 by 20 is 20. And this is 5 by 20. 5 by 20 is 1 by 4. So in the new table it is 1 by 4. And 20 by 20 is 1. So this is 1. And here 0 is there. 0 by 20 is 0. Now we need to find the new elements in the table. So for new element, the formula is old element minus element corresponding to the column into element corresponding to the row divided by pivot element. So if I want to find out the element here, I will find the new element. New element is equal to old element in this place. We will start here. Here we want to find the new element. So what is the new old element in this place? This is 450. So 450 minus element corresponding to the column 400, element corresponding to the row 15. We are going to the key. This is pivot element. So 400 into 15 by pivot element. Pivot element is 20. So this is 450 minus 30, which is equal to 150. So here new element is 150. Likewise we will find all the new elements. After finding the new elements in the second table, just to find out CB and XB. CB and XB. So this is CB, this is XB. 80 into 20 is 1600. 0 plus 150, 0. So this is 1600. And again 80 into 1 by 4. 80 by 4. 80 by 4 is 40. 80 by 4 is 20. 20 minus 45 is minus 25. So this is a negative element. Again we have to repeat the process. because one of the Zj minus Cj is negative. In the same way, again we will find the new table. In the new table, we will find the max Z value as 2200. So this is the maximum profit. So the maximum profit is 2200. Number of chairs we need to be produced is 24. Number of tables we need to be produced is 14.